moving forward, the abstract of this project. Okay, so we have fetched the data from a flight database API, and we have filtered the data on the basis of country code and the arrival airport ICAO code. The project or the system fetches the data from it. We provide the input for the country code. Suppose we have provided the country code for Canada. So the system will hit the API and will fetch all of the records that are related to the Canadian Airlines. And it will directly go to the database. And to reduce the load on the API, we have set a timeout of 120 seconds Spring Boot to manage all of the execution. Moving forward.
Yeah, moving forward to next thing, which is high-level design. So on base of it is Spring Boot. So Spring Boot is handling the start of the refresh task executor class, which will create autonomous tasks to refresh TV, which will automatically fetch new data from API every 2 minutes for flight data and every 120 minutes for new countries code if they are getting changed somewhere, but they won't actually in reality. So all these two refresh jobs will be in parallel state. So and in async as well, so that if somebody is fetching new data from our project, they are not kept waiting because of the loading process behind the scene. And after this, there is also implementation for login. So whatever credentials you have provided to the user, only those can access the our API. That could be done in the login service schema. We'll explore later in the low-level design. And the third thing is we have on high level we have maintained the readability of the code, and we have implemented 2 or 3 design patterns. One as such is DAO implementation layer, in which the business logic is kept in a manager layers, and the logic for retrieving the records from DB or DB interaction code is kept in the DAO implementation layer. This enables us to switch among various databases very easily. In this case, like only we need to modify DAO implementation classes if somebody wants to switch from SQL Server to maybe MySQL or to any other, name it, and you will find the documentation and one can move easily. So this reduces the complexity of the code on a whole, and makes it maybe more versatile, and it's easy to maintain as well. Next thing is the low-level design. So for low-level design, I'll prefer to switch to code view. That will be much easier for you to understand. So we'll start from the backend and we'll come to the code, how it is being implemented. So first thing is the login service. So in login service, we mainly have 2 tables. One is the LU table and another one is LU user role. As the name says, LU means lookup user. So in lookup user, it will be mainly consist of username, the email of the user associated, and user role ID. User could be admin or a normal client or just read-only mode, something like that. And we have implemented audit columns as well. Create user is the person who created this record. Create time of this particular record in this table. Create time is a column itself. Update user who updated the record. Update time. So if somebody changes the record, they are supposed to change these things so that it is easy to track who made the change in the DB. Next column is the password. So the password over here is kept as encrypted. So, and the Spring Hibernate framework will automatically decrypt the password and perform the query to retrieve the user automatically once you log in the UI. Next schema that we are using is flight radar. As the name says, it contains the flight info table, country table, and update history table. So flight info table, as the name says, contains all the flight information which we are getting from the API, from the external API, and country table is also fetching countries from another API, and we are storing it in this table. There is a relation between flight info and country table. The flag in this flight info table is the country code. That's why we have primary key as code, which is a varchar or in Java it is string. And the flag will be such as maybe Canada, United States, or any other country. It will be abbreviation of code like US, CA, something like that. And name will be the full name of the country. And the third interesting table is update history. This table is not updated in the code, it is updated in the DB itself by the triggers. So let's say if we are running into the problem like the flight info table is not getting updated or any other issue that we are facing that we are not able to deal with. So in order to track the updates on flight info table, we have this update history table. So when update is made into country table or flight info table, this table will automatically gets updated using the triggers. So we have triggers for after update, after insert. So this one is for after insert on country table. So yeah, coming back to the code. So as we discussed, there are two classes for flight info and country. We'll check those. So yeah, so the flight info class will contain all the variables or for each record. There will be an object for flight info created in this Java. And this will extend the base Pojo, which will mainly contain the audit columns and audit variables you can say in Java. And this class is kept as abstract because there won't be any base Pojo in the DB itself on its own or base Pojo table. And also there is one abstract function toString that we have implemented. So for each Java class, this will be different. So that's why we have kept in the base Pojo. Let's show over here. So yeah. So how the execution will occur. So the only thing that we need to care is what the main application .java. So once we reach here, we just need to click run as Java application. And there are various ways to run the application. I have documented that in the GitHub. One way is through Maven. We can, for this, you need to install Maven on your system, Maven Spring Boot run, DI profile test. And in order to execute just the unit test cases that we have implemented, you can execute this command Maven test. So this will automatically call the testing framework and will execute the test cases that are written in that class. Next thing is this thing I've already mentioned, Maven is required. And next thing is our application is built on minimum Java 16. So there are some classes that are using the latest functionality for fetching the data from API. So for that, I'm not using any external Java dependency. So there are three APIs. So these are the URLs through which those could be hit, or this could be given to the client so that they can reach out to our DB or interact with our application. So yeah, so our application is up. So we'll try to see first of all in the logs. I'll extend this thing. Admin and password. So once we are logged in, we can hit the API using the Postman. So yeah. So first one is for fetching the flight info with flights or the airlines which are listed in India. So we'll just hit the set button and it will fetch the cards from DB. As the name says, IN, it means India. So this flight information or the flight airline is registered in India and it is flying around the world, and the latitude and longitude is mentioned over here. The altitude 10,000 feet versus speed. And if we remove this filter, so it will retrieve all the records from DB, whichever are present. This could take some time because of my system slowness. And the another API is for fetching flights which are arriving at a certain airport. So this is ICAU code, if I'm not wrong. So the URL says get flight info with arrival airport as this airport code is for Montreal International Airport. I will hit this once this API is done. Yeah, it is done. As you can see, there are lots of record in this. Yeah. So now we'll try to hit the API with the flights arriving in Montreal. Yeah. As you can see, arrival ICAU is Montreal International Airport and airline code is PAW. And the registered country is UK, United Kingdom. So this data will keep on updating every 2 minutes in the Eclipse, in the Eclipse, in the Java code. For the updating updation also, you can see, uh, So our main application will automatically schedule some tasks as it is saying success updating flight info. And in the starting, you will see success updating the country info as well. It should be somewhere over here, maybe before this. Okay. So yeah, coming back to DB refresh. So we are using this component annotation on top of this class. So this will tell Spring that this class is very important. This needs to be loaded. We have another annotation over here, post construct. It will tell to Spring framework that call this function once the Spring Boot framework is up. So as soon as the Spring framework is up, this function will be called. And there are two tasks that are created over here. One is for loading the country's information, and one is for loading the flight information. And these are scheduled for like 120 minutes for countries and 2 minutes for flight info. And this will keep on happening until the application is up. As you can see now, outside is updating the flight info right now from the logs. And for log file, we are generating the logs in this folder logs, and this is my app.log file is getting generated. And as of now, it is, yeah, new logs are already over here. So yeah, so let's go back to the, like I've shown you the code execution and everything. So my friend will start on the next thing. Yeah.
Okay, moving forward. Now, whenever we develop a code, it is not perfect from the starting, so we do many iterations to make it near perfect. So, but to make it easy for implementation, reusability, and easy of access, we implemented some coding standards such as access modifiers, the naming conventions, documentation such as commenting the code in a proper structure, inheritance to reuse methods and interfaces, and abstraction to keep the data separated from the user, like to uh, prevent access. And then we have used separate annotations of Spring Boot and other to implement our functionality. This is more detail present in our report moving forward. After the coding standards, we have touch base with our design pattern. We have implemented three design patterns here. That is DO design pattern that we have explained in the code. Then we have transfer object design pattern that is implemented in our Pojo class, like the base Pojo class. What we are doing here is that we are creating a separate object and a separate variable for each corresponding element in our database. Like for each column, we are creating a separate variable. So that's what we have implemented in transfer object design pattern. After that, we have used the singleton design pattern. In this, we are declaring our constructor as private, and so that no other methods can call this class other than the object of this particular class. So it increases the security of this of our system. Moving forward, we have implemented the refactoring strategies such as abstraction and extract method. In abstraction, we are like removing the code implementation and moving it to a different class. Similarly, in extract method, we are creating a method for the functions that are reused frequently, so that a method doesn't get cluttered and it is easier to read and maintain. After that, we have done the testing in our JUnit. We have used the JUnit that is open source.
For the testing part, we have implemented Mockito. It will like the testing framework itself is a framework, is a very vast framework. Uh, so what we are doing is we are replicating the entity manager. We are creating our own entity, fake entity manager. Instead of hitting to the DB, we are setting our own return record that the DB will, like the fake DB will return us, and we are testing on top of it whether the country implementation is working as intended, or it is like if somebody changed the code somewhere. So the basic functionality of the code should be working as it is. So let's say for code and country names, so these are the essential things for country. So this part should be working as it is intended to be. That's why we are having a cert equals. The country name should not be wrong for this Pojo, and same is for flight info. So we are creating a fake object and we are setting into the entity manager over here, and then we are checking whether the reader is performing as expected or not. So these are the two test cases that we have prepared in order to execute these test cases. As I've shown in the GitHub, you can just execute it using the maven command. I'll just execute it over here once. Uh, okay, yeah, that's one test. And we'll just hit run. So as it is saying, it ran this file db connection test, this file as I've shown, and all of the two tests got passed, and we are the build got success, so we are good. So this is the basic testing that we have done, and like we can add on top of it as many test cases as one want. So yeah, that will be it.
That's all good. Thank you. Thank you.
Thank you. Goodbye.
Bye bye.